Next, we'll turn to thinking about COVID in the medical sphere, and I'm delighted to introduce Dr. Markus Covert. Markus is a bioengineer professor at Stanford. He received his undergraduate degree from BYU and then his PhD in bioengineering and bioinformatics at UC San Diego. Subsequently, he also went to Caltech, where he did his postdoctoral research. He's leading his own lab at Stanford, and he, in 2012, had a really important breakthrough of doing the first software simulation of a full organism on the cellular level. And since that time, he's been leading in substantial ways how this breakthrough science that combines computing and biology can advance work in a lot of areas. So he's uniquely qualified to address the topic of today, the long and very short journey towards our COVID-19 vaccine. He'll talk about the journey there, as well as some of the applications and implications for us today. In his private life, I'll just also say that Markus is very active as a father of two and a new puppy, and also the leader of our local church congregation in Palo Alto. He is also well known as a foodie and teaches many courses in his work through interdisciplinary courses at Stanford, but also one of the hardest to get into courses, which has to do with haute cuisine and the chemistry behind food. But today our focus is on COVID-19 and the vaccine. Delighted to have you here. Thank you again, Markus.
Thank you, Marguerite. And thanks, Russ. It was a fascinating talk to be able to hear, and I really appreciated those responses as well. It's interesting, hearing Russ, thank you all, just made me think, we've all had a crazy year, but it's easy for me to imagine that in this room, everyone could probably share a truly amazing story about what they've had to do differently this year, right? It's been an incredible year of changes, and I'm sure that a lot of weight has probably fallen on you and your work as you've tried to respond in this global way. So thank you so much for all the work you do in that area. So I'll just start my timer here as well. There's a lot of material to talk about. And usually when I give a talk like this, it's funny because it all changes so quickly. So I was just trying to update. There's just a million things to talk about, but I'm gonna actually start, first of all, by just taking a step back and saying, okay, remember, and this is where I work, my work is in virology and immunology and how those things come together, basically thinking about how the immune system recognizes, destroys, and remembers invaders, threats, right? Viruses in this case. And the job of the vaccine is just to improve and accelerate the process. One reason that I've been giving this talk on behalf of Stanford is for outreach, to try to help people who are wondering if they should be vaccinated, to be informed. And a lot of times it's interesting for people to know that we can go back 300 years on this problem, right? 100 years before Pasteur, right? Like very, very early, back to the smallpox epidemic in Boston, in which people were dying. And here's where, at least in the Western world, we first hear about this idea that's now common in vaccines. And in fact, it's told by kind of a Boston civic leader at the time, but it comes from Africa, right? Which I think is something that, the Western world, we often like to, especially in the US, we can be a little bit provincial about who comes up with what, but it's important to know that this was an international thing that happened, right? And in this case, horribly, right, tragically, one of Cotton Mather's slaves, he describes as a servant, but a slave of his, told him about the method that he practiced in Africa to be able to avoid having the smallpox. And in particular, he asked Onesimus, like, have you ever had smallpox? He said, well, yes and no. And then he explained that he had had this operation in which he had some smallpox introduced into his body back in Africa, and that was going to protect him from getting smallpox. And this fascinating comment here, whoever had the courage to use it was forever free of the fear of contagion, right? So just a a really interesting context, especially because we see a couple of themes now, right? This fundamental concept behind vaccination, but also the idea that it requires courage, right? This is the problem that we see right now in the United States. It requires courage. And in fact, even then, there was an anti-vax movement that was violent and crazy. Like, I love this letter written to Cotton Mather. Cotton Mather, you dog, damn you, I'll inoculate you with this. And they threw a bomb through his window. I mean, this was like a real part of the history. And so I don't think it should be surprising that there is this kind of counter feeling. It can be frightening. Even who I would say one of the greatest intellectuals, certainly that the US has ever produced, right? Benjamin Franklin writes a story in which he lost his own child who he had not inoculated. And he wrote this story specifically so that people in his shoes could know that really maybe they should do it, right? That they could learn from his bitter loss. And it's fascinating as well. Of course, Ben Franklin is also the inventor of the double-blind study, which is one of the biggest reasons why we know that the vaccine works, right? It's incredible how these things all come together. So now I want to fast forward a little bit and talk about the worldwide efforts to eradicate polio, because they emphasize these same themes, and it might help to illustrate the different kinds of vaccines, right? So there's a book that I always recommend to my students that they have to read about, which has one chapter about polio. Atul Gawande wrote this book called Better, which is beautiful. I highly recommend it. It's a beautiful book. But it talks, one chapter is about the mop-up, in which they basically what happens is, right now, most of the world, nothing is happening with regard to polio, but every so often there'll be a flare-up. And then what happens is they have to send people and just try to get rid of it as quickly as they can. So he is actually on scene and reports on this from India. And it really is kind of a massive effort to get rid of course, one of the worst viral plagues of our world. What I'm showing you here is some data from my own lab. I hope you'll indulge me. Here are some cells. They're all in green, and you can see their nuclei here where they hold their DNA, and they are going to get infected with polio. So I actually use polio in the lab sometimes, and you'll see polio kind of will, these cells will start to turn red when they get infected. You can see them kind of up here, right? And then what's going to happen, they're going to turn these cells kind of crazy. The cells are going to encourage other cells to eat them up, and then those cells are going to get infected with polio, and it will just go on and on. It's this very pernicious pathogen. And so let me move to the next slide here. And so what they're trying to do let me just say, it's as contagious between cells as it is between people, right? So this virus travels between cells. Those cells are people. People then pass this thing along. And so the goal of the mop-up is to try to get, and if you look at the data here, it's incredible. They're going to go door to door with backpacks that are full of coolers with ice, et cetera, and they are going to go try to vaccinate 4.2 million children in 3 days, right? Which is an incredible feat, right? Nowadays, of course, we know that we're vaccinating more than that worldwide. It's an incredible effort here, but if you think about this little quote up here too, anything less than 90% of the target population is considered a failure. So that is really kind of astonishing. So I'll talk quickly about the kind of viruses, the kind of vaccines that they are using, right? So the original vaccine for polio was an inactivated virus. And so what that means is that they've basically, you treat the virus with some kind of a chemical, it breaks up all of the genetic material, which I'm showing here. This is kind of the capsid, and this is just the genetic material in there. So they break it up with formaldehyde, and then you put it in, you inject it into somebody, right? And it triggers this immune response, right? Another type of vaccine is live attenuated virus. In this case, they grow the culture, it doesn't really matter how, but they have a different way that now what's nice is you can deliver it orally, which is what they do in the mop-up. And interestingly, this virus is still live. So actually your resistance, your immunity is also contagious, right? For the people who've been who've been given this kind of a vaccine. The problem with both of these, and the thing that leads to some fear, right? Again, you have to have courage to take it. There's an extraordinarily low, like 1 in a million, right, or less incidents in which these viruses could revert, right? And so you have this problem, but the incidence is so much lower than the real risk in a pandemic or in an outbreak that this is seen as a really important still to do, right? Both for yourself and the community. And indeed, these vaccines, if you look at the incidence of polio over time, right, the development of the inactivated vaccine, boom, just a huge drop there. And with the oral vaccine, even less, to the point where now we have this unprecedented opportunity really to try to rid the world of polio. But it also comes with these fears. And in this book, one of the most horrible things to read is about this young mother who's very worried about getting a vaccine for her child. And they've been told, we're not going to pressure this on anybody because they want to really maintain a relationship with the community. And so the mother doesn't do it. And a little while later, she comes and her child's legs are drooping and she realizes that it's been too late. And like Benjamin Franklin, again, across these hundreds of years, she is also caught in this hard place, right? Where it requires this courage to make this difference. So just quickly, to contrast with mRNA particularly, because that's what I was asked about, there are several other types of vaccines, right? So the H1N1 kind of flu vaccine, typically the idea is you want to get away from using a whole virus because it makes it safer. You're not worrying about a virus becoming active again, right? And so you have things like this. I'll skip this live recombinant rabies virus for now, but if you think about this subunit, right, you're just taking some proteins from the virus and there are fewer side effects, but it also doesn't give you as much immunity. So that's this trade-off, right? You want to be able to get immunity. And so people have also tried to do things with, for example, DNA, where you bring it in and maybe the cell can make its own pieces, its own subunits, right? And DNA is still seen as an interesting possibility, but it has this, because it's DNA and it has a chance to interact with our cells, there's this lower risk than the polio virus, but still a risk of something happening with cancer, for example. Enter into all of this mRNA vaccines. So I've been lecturing about mRNA vaccines for a decade. And every year I talk about them and I say, it's just too bad we don't have them because theoretically they solve all of our problems. Because it's mRNA and not DNA, it's not a cancer risk. Because it's not the whole virus, we don't have to worry about the virus, right? So it has all of these advantages. And so I'll tell you what they do. It is absolutely incredible to me that just when we need them, we've been able to produce them. They were not developed for COVID. This technology has been online or has been in progress for a long time. So the specific idea is that you get a piece of RNA, you design it and engineer it to make part of the virus. And in our case, it's the spike protein. The reason you call it a coronavirus is because it kind of looks like a crown, especially if you look at it under the microscope, flat, right? It kind of looks like a crown. And these spike proteins are what give you the little points on the crown. The spike protein is what basically enables it to infect. It's the dangerous part, so to speak. It's the wrong end of the gun. And it's something of great interest. In fact, a lot of work is going in right now to sequencing the proteins. I'm showing you these protein sequences and trying to see what's different about previous coronavirus spike proteins that we don't have now. It's then introduced into our immune cells using what are called lipid nanoparticles. And as much as we talk about the vaccine itself, this carrier is also a brilliant piece of work, truly amazing work. And talking to Moderna, they made a decision right away when the virus came out that they were going to have the lights on 24/7. They immediately shifted into 3 groups, doing overnight shifts, doing all kinds of things to make this happen. And part of it was just figuring out, all the delivery, et cetera. Here's this can get a little bit into the weeds, but I'm a scientist. Sorry, I can't help myself. So what you see here is kind of a cell, okay? And what happens is when one of these lipid nanoparticles comes in with the mRNA, It goes into the cell, it gets translated, and then you start making pieces like viral pieces. That's this right here, pieces of the virus, the spike protein. Those then get broken up and they get presented on the outside of the cell, whatever cell it is. And the cell is basically saying, hey, I'm sick. I've got this foreign stuff inside of me, which activates your T cells. Okay. And those T cells are what are going to essentially lead you to create memory in your body, right? An immune response in your body. And so it's really kind of an ingenious method. I can't say that enough. Designing, one interesting thing about mRNA vaccines is the pipeline tends to be the same. We're very good at sequencing or building, synthesizing mRNA. So once we do that, we're able to use this pipeline of introducing it into the nanoparticles, et cetera. And so, as I said, making the genetic material is straightforward, not even that expensive. Moderna did this in 66 days, which is pure miracle, right? It's amazing that happened. We sequenced this. I think we got the sequence from China in 1 or 2 days. From what I understand, Moderna had put parallel teams together to try to work on this in parallel because they didn't want to get stuck in some local solution. But it turns out all the teams quickly converged on the right way to do it. 66 days, we've got a vaccine. Okay, and like I said, it doesn't have to be, we don't have to use the virus to do this, and it makes it much safer. DNA approaches could interact with host DNA. We don't want to do that. But as I find all the time in my lab, and which is a real pain, RNA is less stable than DNA. DNA is super stable, RNA is not, and that's the shelf life problem. It makes it a difficult thing to introduce the same way that we did in the polio mop-up, for example. Okay, does it actually work? So here's the original finding. I think a lot of times people say we just don't know enough or we haven't seen enough. That might be a reason not to want to be vaccinated, right? We just don't know enough about this. In fact, we know more about it. Like the silver lining of our problem is that we have tons and tons of tests that have now been performed, right? Millions upon millions of people have been vaccinated. And so even in this clinical study, again, a randomized double-blind study, which we wouldn't have if not for Ben Franklin, 44,000 roughly participants were given this vaccine, which is just a gigantic number. Clinical trials usually never have something this big, certainly not at this rapid rate. And so it speaks to both how serious the pandemic was, but also it should give people a lot of confidence. And what you see here is very clear. Here is cumulative incidence of the virus, so people getting the virus, and this is where they get a placebo. Again, Benjamin Franklin's suggested placebo. And then here are the people who've received this vaccine, in this case, the Pfizer vaccine. And what you can see is the incidence just drops so significantly. After dose 1, it's just very, very few people are getting it, even after dose 1, but certainly after dose 2, which is where you get your 95% efficacy, you can see it's a 95% effective greater than 7 days after dose 2. And we have comparable numbers for the Moderna vaccine. Are there side effects? I'm sure many people on this call probably remember some of their side effects at this point, right? I certainly had some, but you can see them here, right, for the Pfizer. Some people say the Moderna is a little bit more, but I think they're roughly comparable. And you can see that sure enough, there are things like fever, fatigue, headache, chills, in some cases vomiting. One thing that was interesting for me, my old boss won the Nobel Prize when he was 36 years old, and he's a virologist. Now he's older, David Baltimore, but he and I kind of had a running bet about the loss of taste and smell. He said that it came from your own immune response, and I said it came from the virus. Of course, I should never bet against A, my boss, or B, someone who won the Nobel Prize when they were 36. He was right. When I got one of the side effects of my second shot was that I lost my sense of taste and smell again briefly. So from that, we know that it must come from the immune response, which is really interesting, even though that's only one replicate, but still pretty interesting. How long does it last? Jury's still out on this, but right now it looks like it's lasting, right? In fact, just to go quickly here, these are some of the leading people in immunology. I send this to my friends who aren't scientists all the time. This is a great opinion piece where he talks about the fact that that even though people have seen that the antibody counts appear to be going down, really a lot of your immunity doesn't come from your antibodies themselves. They come from the cells that produce them and the other immune cells in the body. So it looks like his prediction is bearing out, that really we are having lingering immunity, which is great. But what about these new mutated viruses? Yeah, it's concerning, right? There's a whole report on these now come out of Johns Hopkins talking about the variants. The B117 variant was identified then as being pretty serious. And sure enough, right now it's the most prevalent strain in the United States, right? It really, these things can spread. The good news appears to be, so I'll talk some other variants. You know, we see in Brazil, there's this P1 variant. And if you just look here, both of these continents, you would expect to have a decrease just due to seasonal decrease, right? But you can see that very unfortunately, South America is being taken over by this P1 variant, and it's had a huge impact on the caseload. And of course, it's not just going to be these variants, right? There's going to be more what's called genetic drift. And so we really have to be careful about these things. The good news is it looks like at least the Pfizer and Moderna vaccines are still effective against the most common variant. Maybe not against the others. This jury is still out on this, but it's an important place to keep looking and thinking, because we may have to make new rounds that are effective against the other variants. And here's the data, which I'll just go through very quickly. You can see that essentially we're equally good. You can, because these lines are close together, what that's telling you is that we're essentially equally good at preventing both the original strain and the variant strain that's now the most common in the US. Okay. Same thing has been found at UCSF, for those of you up in San Francisco. And they recommend 4 major priorities that are kind of at this policy level, right, to try to help us to prevent the problems associated with variants. And one of the biggest ones, of course, is just going to be, this is why we continue to wear masks. This is why we are continuing to trying to get as many people as vaccinated as possible. Okay, I'm just going to show, I'll try to go really quick. I want to show a couple updates that are just like yesterday, right? So that you can get the latest information. So the vaccines are now coming along. You've probably seen, like, there's a huge proportion of many countries that are getting the vaccine, but certainly not everybody, right? There is a real need for the US and other countries in particular to help these other countries to get vaccinated if they can. Around here, though, it's been remarkable, right? We see a very large fraction of the population. They continue to be vaccinated. You can see the breakdowns. It's mostly Pfizer and Moderna. And you can see this is showing you the fraction of the population that's been vaccinated. And here are projections based on that. So, and here's the projection as it's been changing over time. So there has been a slowing here, right? And of course, it's not unexpected, but it is going to be harder and harder to get the next group vaccinated, and we'll have to keep working on that, right? Trying to figure out how to help people make those decisions. And there have been all kinds of different strategies at kind of a motivational psychology level. But in Santa Clara, it's been truly remarkable, right? We have a very large fraction of the population that's now vaccinated, and it will continue to be that way. I want to mention briefly India as a cautionary tale, right? It's been extremely heartbreaking to see what's happening in India and South America. One of my friends and a so-called MacArthur Prize winner, genius scientist, right, who is in my who I work together with, he wrote an op-ed about this, just talking about how newer variants have transformed the pandemic. We can't just vaccinate rich countries and hope that everyone will be safe. the only way to end this pandemic is to end it everywhere. I think that's a huge message that we need to think about. And he makes this case, which is absolutely right. Otherwise, we'll always be playing whack-a-mole with a constantly mutating virus. So at the end, I always tell people, should I get vaccinated? Should you get vaccinated? Yes, definitely. And certainly in this country, it looks very much like the Bay Area is entering a place where things can look almost normal as we start to hit these projections. Most of the projections now are thinking that a majority of us, and certainly a large majority of the Bay Area, will be vaccinated, and that will bring us able to do all kinds of things we haven't been able to do for a while now, and also hopefully enable us to start moving our focus with more aggressive priority towards some of these other countries. So with that, I will close, and I'm happy to take questions.
Thank you very much, Markus. Who would like to start off with a question? A lot of food for thought, for sure.
Yeah, I gave you a fire hose. Yes, David Sangster.
Yes. Hi, Dr. Covert. Thank you for drowning me.
Yeah, it's a pleasure.
Look, this is a pretty complicated topic. What I'm looking for, I have a day job in addition to my honorary consul duties. I'm a chief operating officer at a software company in the Bay Area, and we're struggling with the back to work, return to work sort of notion. And what I'm trying to get a sense from you is, do you have any recommendations for sort of businesses, one, but just sort of public health guidance, two? And the reason I'm asking is, MIT produced a paper very recently, you may have seen it, on the 6-foot rule, sort of not poo-pooing, but saying it doesn't apply in every case.
Yeah.
And it's an interesting paper, and they give you a model you can go and play with, indoors, churches and schools and so forth. And my sort of takeaway was, it was actually really insightful because it allowed you to some control of the environment. But the takeaway was, look, if it's a small place, it's enclosed, if people without masks, don't go in. It's pretty kind of common sense sort of stuff. But yet I struggle with that, because then I go, wow, but we're opening up bars. People aren't wearing masks, people are talking. So how should we think about this whole return to work? We're not quite at herd immunity. I know we want to unleash the shackles, but if you do too soon, you can get back into a fourth wave. How should we think about this progress we've had so far?
These are really fascinating questions, and I should say, maybe as a disclaimer, right? Because I'm not authorized to give any kind of policy thing, right? But as an academic, I always get to say whatever I want, which is nice. But I'll just say at the beginning, take all of that with a grain of salt. Some of my favorite work in this space has actually been done in Korea. It's interesting, again, how some studies don't get passed around between countries, but I've really been interested in watching Korea's response and their Center for Disease Control. They did a few studies that have been fascinating. One of which was actually in a building. They had a building that was multi-floor, and interestingly, both halves of the building were ventilated with different ventilation systems, right? So they were disconnected, but they did share a restroom. And so, for example, one thing that you saw when you looked at the cases, all of them were on one side. So what you could learn from that is that nobody was getting it from sharing a restroom, for example, but people were getting it from the ventilation system, right? And maybe you've seen some of these amazing graphs. There's this one incredible outbreak that happened at this restaurant where you could see where the air conditioner is located and the airflow, and they just labeled people in order when they got the virus, and it's just like right down the airflow, So going into a place, I think there definitely are big picture things you should consider, right, before you make that decision, right? Just, okay, what's the ventilation going to look like? With what confidence are people going to be compliant with the mask? The other thing that's been really fascinating to see is in our ICUs, in Boston and in the Bay Area, people who are working in the ICUs have had a lower incidence of COVID than the general population. And the reason is because they are taking masks and that kind of stuff seriously, right? So compliance, so we know a few things, right? We know that ventilation is an issue. We know that compliance is an issue, right? I think bars is a fascinating one, right? For me, I would prefer like an open or outdoor arrangement. California is really nice for that. The third thing I would say is that vaccines, like the polio vaccine, in comparison to the Moderna vaccine, the polio vaccine is 50% effective. Okay, so there's this trade-off between how many people get vaccinated and how effective the vaccine has to be. We're fortunate to have an incredibly effective one. If we can just get a certain amount of people to take it, that herd immunity will probably kick in and the rate will go down for everybody. So those are some of the key little things that are all coming together to create, you know, the policies we adopt in the Bay Area and California and in the country. Yeah, so I could go on this forever, but I don't want to open another fire hose. Yeah, thank you though. Anybody else?
I have a question for you, Markus. One is, since we're a global community, can you tell us a little bit about the testing population? How diverse was it especially for some of the leading vaccines?
Yeah, that's a great question, and it's it's another tragedy in my opinion, right? So was not like this study that I just showed you was predominantly white, right? Very little, and it has caused problems, right? It's caused a confidence problem. I know that there are like in the Asian population, for example, which was very lowly represented in this study, it has led to some confusion that maybe it's less effective for Asians, Asian background, because there just weren't enough people in that to give you the same confidence. Like, oh, is this maybe less effective? And the only way we do that is by having a diverse population that is brought in. So I feel like we need to do a much better job of trying to be inclusive. Several people have said this now. It also does impact our global distribution as we start to look at other countries. Maybe I'll show you one interesting graph here that I thought was really fun and that you can actually access on your own if you're interested. It's it comes from a group called KFF, which is a foundation here in the Bay Area. So I'll just share my screen. So you can see here, people as a share of the vaccinations, percentage of cases, percentage of deaths, and percentage of the total population. And you can see it by state, which is a really nice way to present this data. But going back to what I was telling you, so here in California, you can see the fraction of kind of white people who are being vaccinated versus the cases that they represent, the deaths that they represent, and the percent of the total population. And what you can see in this case is that clearly white people are overrepresented in receiving the vaccination, right? You can also see that, let me go, I think this one is maybe the most telling, right? 26% of the vaccinations are going to the Hispanic community, whereas 63% of the cases are coming from the Hispanic community and 48% of the deaths, right? So it's like this really obvious how important, and you can see this also very much in the well, not as much just because the overall percentages are lower, it's harder to tell, and I'm focusing on California here, but you can see in some places like it really gets quite egregious where you might have very low percentage of the vaccinations and yet the lion's share of the deaths coming from a different population. So I recommend, if you're interested in that, it comes from this group again, KFF, and you can look at their coronavirus reports.
Thank you so much, Dr. Covert, Markus, for your fascinating presentation. Now I'd like to turn it to Dal Wilson, who is, like all of us who are part of the church here, have two hats. He's just finishing a remarkable leadership role as the CEO of Varian, and in our church, he serves as the leader for our part of California. Dal, Elder Wilson, would you like to say some words?
Yeah, just briefly, the shortest thank you in history. I don't want to keep anybody any longer. We're so grateful that you could join us today. Wonderful to see everybody. we've been able to do this annually in the past. Of course, had to cancel last year, but look forward to getting back in person at some point. Markus can guide us. We'll make sure the ventilation is well filtered and masked or whatever, but at some point we do look forward to being back together. We would like to welcome Russ and Marguerite. Of course, they've been very much a consistent part of this ever since it began under the direction of Boyd Smith. I saw Boyd was on earlier. Boyd, if you're still out there, thank you for your leadership on this. The implementation of the remote technology today has been flawless and has given us an opportunity to meet without having to travel to I think a couple years ago we were in a conference room at a country club, and before that at a conference room on the Stanford campus. It's nice in some level to do this on this kind of quick visit with Zoom. Having said that, we also look forward to getting back in person. I'd like to thank our sponsoring organization, as well as Marguerite mentioned. I'm in charge of our church in charge. That's a loose word, but we have about 70,000 members here in the Bay Area, and of which Markus, Russ, and Marguerite are all members, and I'd like to thank them for their leadership and contribution. One of the things that's unique about our church is it's a lay clergy, so nobody is compensated for their effort, and it keeps a certain kind of purity in the church, which is beautiful. But anyway, we just want to thank you for joining us today, and if we can answer any questions. It sounds like Markus and Russ are going to hang on a little bit. There was one question I saw in the chat, Russ, relative to the effect of the proposed Biden economic recovery plan on California. Sounds like the coffers, at least with the market cap of everybody going up so much, the coffers are in good shape. But what might maybe turn it over to you for some questions. Please feel free at this point to leave if you want to leave. But Russ and Markus have graciously agreed to answer some additional questions if you'd like.
Thank you so much for adding your words. Before we formally close this part of the program, and Markus and Russ will be here for another few minutes, I do want to say thank you to each of you, and also the team, Matt Ball, the Hales and Kellys, who have been important partners. They're based in Los Angeles. We want to invite you, each of you, to fill out a survey. We'll be following up right after this program to ask if this was valuable, if you would be interested in future meetings, whether they're on Zoom on specialized topics or in person, as we look forward to gathering together and continue to build bridges. So please, if you have just 3 minutes, fill out that survey. That will help us as we try to serve this part of the community for future events. So with that, this concludes the formal part of our briefing for today. And Russ and Markus will just now open this up to an informal conversation.
No offense, as you all drop off, we'll take absolutely no offense. We know your time is really valuable. But if anybody wants to pose a question to Markus or myself, we're happy to field them. I'll take the one that was in the chat, which was, as Dow mentioned, about President Biden's infrastructure plan and what might that mean for Silicon Valley and for the Bay Area. It does mean that there will be jobs. It will add to our job total. And those are the kinds of jobs that are most needed by that segment of the community I was showing you in those slides, where there has been joblessness and other forms of economic devastation. So it's no different from any other part of the country, but we find ourselves needing jobs, and especially in the area of infrastructure. So that's one observation. But the second observation is to say that the kinds of investments that the president is targeting are things like roads, bridges, transportation improvements, and rail, including high-speed rail. And this is something that has just been a boondoggle for our state for about now 20 years. This will amuse you if you're coming from Asia or if you are coming from parts of Europe where rail systems are in place, including high-speed rail, including maglev and other fabulous forms of transportation. But here in crazy California, we have not been able to get that done for a host of reasons that I could detail for you. The Biden plan might make it possible to actually build high-speed rail in California. And by that, I mean a rail system that would connect Silicon Valley to the Central Valley and then also connect it to Los Angeles and even beyond to San Diego. That would be a breakthrough for our economy for a couple of reasons. One, it would take tremendous load off of our transportation system, but it would also be enormously helpful because of our housing situation. It essentially makes it possible for us to extend our bedroom. It's like remodeling your house, and it makes you able to add bedrooms to your house in farther flung places. So for example, it means that people in Los Banos, people in Fresno could actually be filling Silicon Valley jobs, good jobs, tech jobs, but having affordable housing in the communities where they live, and they could be to work in 30 minutes. I mean, that's the promise of high-speed rail. So the Biden plan holds that possibility for California if we're able to overcome the politics and all of the rest. Now, questions for Markus or for myself? And you do have to unmute yourself if you're going to. Yeah.
I guess.
David.
I guess I'm the talkative one here, so I'll keep abusing you as long as Ms. Hancock will let me. So I don't know who the question is perhaps best posed for, and it's a bit of a I'm not quite sure how to phrase it, but look, I think the worry. I want to follow up my earlier question. And the worry I have is, tech has been really focused on shareholder value, right? Mm-hmm. Make shareholders wealthy and so forth. Fine. But it's become increasingly apparent to me that you have to both do well and do good if you want a community to sort of work, right? That Gini index really rocked me when I saw it.
Yes.
Like, wow.
Yeah, it's amazing.
It struck me as, and I'm just wondering, this is as much a political issue as it is a technology one, right? Yeah. We can do vaccines all day long, but if I don't solve the political problem of getting it equal access to people to, make that, it's going to keep splitting into groups of the haves and the have-nots.
Yep.
Right. And I'm just wondering what your thoughts are from a policy or political standpoint. How do we get at it? The technology can be solved. There's enough great minds working on this, but if there's not enough equal attention paid on the sort of social side, I think we're in for a rough future. I think you're asking something really important. I think you're also asking something that's really hard to answer. There are two ways that people think about this, and you will find both kinds of people in Silicon Valley in plentiful numbers. The first way to think about it is, why are you beating up on these companies? These are just good companies. They're putting out good products and they're making jobs and they're solving the world's problems. It is not their responsibility, however, to solve community problems. That's somebody else's responsibility. That's in the domain of politics. And let's never, ever forget that the reason companies exist is to return value to their shareholders. That's their only reason for existing. So that's one way to think about it. And like I say, plenty of people think about it that way. There is another set of people, however, that think of the tech companies, the fabulously successful tech companies, as part of the problem and therefore needing to be part of the solution. Now, what's so interesting is that in Silicon Valley, the tech companies themselves have come to feel that way. They really do have this sense that they're contributing to some of our externalities, traffic congestion, overcrowding, and they are willing to step forward and be a part of the solution. They do it in a variety of ways. They do it by supporting organizations like mine that are taking macro approaches. They do it by
their own generosity by reinvesting in communities, building housing, participating in other kinds of infrastructure projects, but also investing in housing outright. Housing. They're doing all of those things, even though they haven't been forced into that posture by the heavy hand of regulation. So both things are going on, and and what's also interesting is that there might be people that even hold both points of view, and it's going to take a lot of sorting out. But what I can tell you is that these issues are on the agenda, that there is a new commitment on the part of the region's leaders to not only build back, but to be building back better. And we're seeing new partnerships form, new combinations form that are trying to get at some of the systematic causes that are underneath things like the lack of mobility for those segments of our community. Those things are happening now with more intensity than I've seen to this point in my career.
If I might take a little bit of a, am I muted?
Nope, you're there.
Can you guys hear me? Oh, okay,
You're
great.
clear.
Okay,
Yep.
if I might take a little bit of a contrarian view.
Oh, sure. That makes it fun.
You know, I see. So I take your point that pre-pandemic, I was seeing personally a lot of the investment community. In fact, the Salesforce has led that, I think, and led by example in many ways in the San Francisco area in particular. What I'm seeing though is I'm seeing that the post or pandemic issue, we can attract talent beyond where we live, right? People work remotely. And I think I worry that it's being viewed as a reason not to do all the things you described. Why do I invest in community if my people aren't living here?
Yeah.
So I'm seeing little sort of, trails of smoke, not a raging fire yet, but I'm definitely seeing I was in some CIO and some CFO conferences recently. And there's some folks, to your point, folks on the left and one side of the fence are looking as an opportunity to de-invest in the community. Yep. I can get rid of all my real estate. I don't do all these things anymore. I don't hold housing because I have this out. I have this out now.
That's right.
So how do you think about that?
You know what? Again, no real good way to answer this question. The fact is, you'll find companies that do exactly what you are describing. They'll say, "Forget it. Our people can work remotely. It doesn't matter. We're global companies. We're not attached to any one place. It just so happens that our headquarters is located in Silicon Valley." There are companies like that. There are also other companies that feel completely differently. They feel like the community matters, that they need to be role players and investors, and they're continuing to do that. So it's the most important thing I can tell you is that tech is not a monolith, that these companies have a diversity of opinion on that very question. However, it is significant that the biggest companies are saying officially through their official representatives, including the CEOs themselves, that they're here for good. They are investing in Silicon Valley as a community, and they intend to continue doing so. I'm talking specifically about Google, Facebook, Apple, Netflix, and then numerous others.
I have a question.
Oh yes, please.
This is I'm sorry, I'm not in video, but thank you so much for this session. Is amazing and it was very informative. Margaret, I just say hello to you and then thank you again. Nice seeing you again.
Good to see you too. So glad you're here. Please go ahead with your question or comment.
Yes. So anyways, I was wondering, do you have a program? Because I'm in Senegal, I know they have the Institut Pasteur, who's doing a lot of research about this pandemic and other, things happening there, like as diseases. So do you have a program where you work with this international, doctors or institution to be able to, because Marcus said something very interesting earlier that if you want to eradicate this situation, these diseases, you have to work on every corner of the world. Like, for instance, this how you put it. Do you have any way of working with this institutions or research places where in internationally you can work together to see how you can eradicate and help the communities in the other countries?
What do you say, Markus?
That's a really great question, and thanks for asking that. So I know that there are definitely initiatives through, for example, the WHO and things like that that try to bring different countries together. I think that definitely we could do better on this, right? Like I think, for example, you may know the Johnson & Johnson vaccine is not an mRNA vaccine. There are other cases where mRNA vaccine has a lot of advantages, but there are lots of vaccines that are coming through, and a lot of the technology is such that other countries could develop, vaccines that might be more appropriate to their particular situation, depending on how it's going to be distributed, et cetera, right? So I don't think I would recommend, for example, the requirement for ultra cooling, that's required for some of these mRNA vaccines might just be too much for different places. And so I think sharing information, I've been really excited to know, both privately and in a recent public announcement, that Moderna is planning to distribute, in a variety of countries. They're planning to distribute these things with open IP and essentially letting people go through and use that technology. I hope that will happen in other cases as well. But you're right. And as a scientist, I guess I'm not as familiar with the policy going on here. I think there really is an opportunity here for us to come together more closely. Like, one of the things that we've learned many times now, but I think the first time that a lot of people woke up to this was in the Ebola outbreak not too long ago. Like, an infection right now, an infection anywhere in the world has become a threat to everyone in the world, right? And this is something that we just haven't truly taken on at scale until this pandemic, right, where we really saw it blow up. But I hope that we start to recognize that that's the case now, right? That almost kind of like our weather system, where we have these international agreements about sharing our satellite data, et cetera, so that we can have a global picture of what the climate looks like and where hurricanes might end up or whatever. We kind of need the same thing for pandemic, where we are all sharing sequences of the new viruses together, and it's coming together in some unified way. I really hope that we see something like that, and that it brings our countries closer together.
On that note, it is 1:30. We are mindful of all of your times, and both Dr. Covert and Dr. Hancock have their day jobs to return to. We want to thank each of you for spending part of the day together. We hope that this has been valuable. Certainly, it's an important time to draw all of us together as we face both the challenges and opportunities for coming out of the pandemic. We look forward to following up with you. Please do share your thoughts on this post-event survey, and we look forward to reconnecting, whether it's virtually or in person soon. Thanks again.
Thanks,
Bye-bye.
everybody.
Great to see you all. Take care.
The last ones.